Programming languages. Natural language has ambiguity and imprecision problems when used to describe complex algorithms. Programming languages. Natural language has ambiguity and imprecision problems when used to describe complex algorithms. Programs expressed in an unambiguous, precise way using programming languages. Every structure in a programming language has a precise form which is called its syntax. And every structure in programming language has a precise meaning which is called its semantics. A programming language is something like a code for writing down the instructions that a computer can and will follow. Programmers will often refer to their program as computer code. The process of writing an algorithm in a programming language often called coding. High-level computer languages. High-level computer languages are designed to be used and understood by humans. Low-level languages, computer hardware can only understand a very low language known as machine language. Compilers then convert programs written in a high-level language into the machine language of some computer. So here's an example of adding two numbers in a low-level language. So first, load the number from memory location 2001 into the CPU. Then load the number from memory location 2002 into the CPU, and then add the two numbers in the CPU. Then store the result into location 2003. In reality, these low instructions are represented in binary numbers such as 1 and 0. In a high-level language, the same set of instructions can be written as C is set to A plus B. However, this needs to be translated into machine language that the computer can execute. Now let's look at what a compiler does in a graphical representation. So source code is translated into machine code by a compiler, and then the CPU will run the program while getting the necessary inputs and sending outputs to the user. Interpreters simulate a computer that understands a high-level language. The source program is not translated into machine language all at once. An interpreter analyzes and executes the source code instruction by instruction. And here I have a graphical representation of what an interpreter does. So compiling versus interpreting. Once a program is compiled, it can be executed over and over without the source code or the compiler. Compiled programs generally run faster since the translation of the source code happens only once. Compiled programs are platform specific, meaning that the executable code produced from a compiler for one machine won't run for another one. If it is interpreted, the source code and the interpreter are needed each time the program runs. Interpreted languages are part of a more flexible programming environment since they can be developed and run interactively. Interpreted programs are more portable. If a suitable interpreter already exists, the interpreted code can be run with no modifications.